Okay, so we've been talking chapter 2, and we've talked about taking proper measurements. We've also been talking about significant figures, how to count significant figures. Again, a reminder in terms of significant figures, as we talked about, all non-zero numbers are significant. Any zero that comes before or a leading zero are not significant. If we have a trapped zero, it is significant. And again, if we have a zero at the end, in order for it to be significant, you do need, again, a decimal place or decimal point written in the number, and that will make all the zeros that come at the end significant. So as we've been talking about, remember that you really do not start counting until you hit the very first non-zero going left to right. And then at that point is really where you should start counting your zeros or your numbers when you do it. We also talked about when we do calculations and that involve significant figures and how many significant figures our answer should have. We talked about when we multiply or divide. And in this particular case, it is the number of sig figs we're looking at. And it is the least. And that is what your answer should have. So again, your answer should have the same number of significant figures as whatever number has the least number of significant figures in your calculation. Same thing with addition and subtraction. It is a little bit different. We do not look at significant figures, but we do look at decimal places. And that's what you want to look at. And once again, it is the least number of decimal places is what you're looking for. And that again is how many decimal places your answer should have. The idea that again behind that is really the one with the least kind of decimal places are significant figures. It's pretty much your worst measurement. So again, your calculation is only as good as your worst measurement, and that is the case there. Any questions on that there? Obviously, if we do some combination of those things, you want to kind of keep track of it. You do not want to round too much until the very end, but you really should keep track of the significant figures throughout your calculation. And it really is usually the sort of last calculation or kind of type of calculation that you do at the end that will really determine where you should end up. So again, if you started multiplying numbers, you want to look at the sig figs, but then if you're adding a number at the end, then you want to transition to decimal places. It's a really good idea to take everybody to a good number of digits past where you should end if you're going to continue on with the calculation and not round too much until the very end. Remember that scientific notation is a good way that you may have to use. In addition, you may have to use it to get a number to the correct number of significant figures. So because you really could control the number of significant figures you have, and that is however many numbers you write here, you could use it really to lay up as many significant figures as you may need. And again, I think we maybe did an example, something like 12,000. And if we wanted to write 3 significant figures, there really is no way to do it in sort of decimal form. Again, if I put a decimal at the end, that's too many. Obviously, if I put a decimal here and cut off the last zeros, that's now 120, which is not 12,000. So really, again, if you needed 3 significant figures, the only way to do it is to put it into scientific notation. And at that point, we would have 3 significant figures. Remember that when you go from scientific notation to sort of decimal form, you never should lose significant figures. So again, you always want to maintain the proper number of significant figures as you go from one to the next. And you do not need to give the answers for me personally in scientific notation all the time, unless I specifically ask you to do so. But you can if you want to, but you do need to give the answers to the correct number of significant figures. Any questions on any of that there? Okay, so towards the end there, we were talking about some prefixes or getting into prefixes and equality, and I kind of jumped a little ahead and we kind of talked about the idea of dimensional analysis, and that is really where we do show calculations involving units. And again, from any equality, we could write two conversion factors. So 1 kilometer is the same as 1,000 meters. And that kilo prefix works for any unit. So 1 kiloliter would be 1,000 liters. 1 kilogram would be 1,000 grams. So basically, kilo represents 1,000, and it doesn't really matter what the base unit is. And from any of these sort of conversion factor or equalities, we can write two conversion factors, and they're just fractions. So 1 kilogram over 1,000 grams, or 1,000 grams over 1 kilogram. So these conversion factors we'll use in calculations, again, to cancel out the units. Thank you. And, you know, if we had something like 55 grams and we want to know how many kilograms that would be, we would again set it up like this. And again, showing the units, so opposites cancel. So grams are up on top. So I would need to use the grams in this fashion in the opposite location so that they would cancel. And 1 kilogram up on top. Grams divided by grams will equal 1 and basically cancel out the units. We would take calculator there. Maybe. We would take 55 divided by 1,000. And we will end up with 0.055 kilograms. And what we are doing here is multiplying whatever's on top, and we're dividing whatever is on the bottom. So this is what is referred to as really setting it up through dimensional analysis and using these conversion factors to do these. And when you take chemistry like you're taking now, this is the way sort of the setup to problems should look, should include the units and those things sort of canceling out. Any questions on that? We'll do some more examples, obviously, a little bit later on here. Now, I think we talked a little bit about the prefixes earlier, and a reminder that, and this is a table from your book, looks like it's table 2.5, of all the different sort of prefixes. And it is important, again, to remember how to properly use this. Most of the time, or a lot of the time, we'll use sort of this version of the prefix, which is really the scientific notation. So when it says, for example, I'm getting old, so I'm going to lift that up to see what that says. That says 10 to the 9 there. That is actually 1 times 10 to the 9. So that's basically what the scientific notation part is. If we look at something, say, like centi, for example, which is C, that is 10 to the minus 2. So a reminder that the way this works when you look at this column here, that is how much there is in the base unit to one of the prefix units. So what that means is if I had 1 centimeter, which is the prefix unit, the base unit here would be meters. That would equal 10 to the minus 2 meters, or basically 1 times 10 to the minus 2. It is a very common mistake that people reverse that and go 10 to the minus 2 centimeters equals 1 meter, and they do it backwards. It doesn't matter the base unit, as we saw on the previous slide. You could have 1 centiliter. Liters would be the base unit, would be 10 to the minus 2 liters. If you did it for our, back this way, right there, we'll do kilo. Kilo is 10 to the 3. So once again, in 1 kilometer, there would be 10 to the 3 meters, and 1 times 10 to the 3 is 1,000. Yeah, so that's how the other number comes about, is basically what that is. If you had 1 kilogram, that would be 10 to the 3 grams. So that is the proper way to use those conversions. Again, very commonly misused by people. So for example, here, mega is 10 to the 6. So in 1 megagram, there would be 10 to the 6 grams. So that is, again, this is the proper way to do it. So when you see 10 to the 6, 10 to the minus 2, in terms of the prefix, that is how much there is in the base unit to just one of the prefix units. And obviously for any of these, we could write two conversion factors. We could say 1 kilometer is 10 to the 3 meters, or 10 to the 3 meters is 1 kilometer. Now, look, I would say probably the best move to do is if you have a conversion where you need to go from like a prefix to another prefix, I would highly recommend that you don't try to figure out how many decimal places to move it or the conversion, because most people will screw that up. I know there's like a song you can sing, I think. But the best thing to do is, probably because you'll have access to this table, is to take it from the first prefix unit to the base unit, and then take it from the base unit to the next unit. So for example, here, let's see here, we'll go up here. We'll do it on this page. So let's say, actually, clear it here. Let me erase all this here. All right, so let's say that we had 12 kilometers, and I want to know how many millimeters that would be. So that's like a prefix to a prefix type of conversion that we're going to be doing. So again, instead of trying to figure out, all right, kilometers to millimeters, and since you won't have the access of just asking your phone, right? So you need to be able to do these things. So the best approach in this case would probably be to take it from kilometers to meters, because you will be able to find that conversion on a table like this, and then go from meters to millimeters, which you would also be able to easily find the conversion on this page. So let's take a look at that. So earlier on the previous slide, we saw kilo was 10 to the 3. So we know kilo is 10 to the 3. We also know milli, which is on this page, is 10 to the minus 3. So milli is 10 to the minus 3. So we can come up with our couple of conversion factors. That means that in 1 kilometer, there would be 10 to the 3 meters, which would come from this guy. That would give us 2 conversion factors that we could use, which is 1 kilometer over 10 to the 3 meters, or 10 to the 3 meters over 1 kilometer. We also can use this guy as so. That means in 1 millimeter, there are 10 to the minus 3 meters, right? So that is what that conversion basically represents. We also could write 2 conversion factors for that. 1 millimeter over 10 to the minus 3 meters, or 10 to the minus 3 meters over 1 millimeter. So conversion factor really is just a fraction that we're going to use to do the conversion. So if we were going to convert these 12 kilometers, that is what we would start with. Now, once again, kilometers, although it's not really written as a fraction, it is on top. And so basically here, we want to put kilometers in the opposite location so that they cancel. So opposite units will cancel each other out. So if we look at our options, we actually want to use this option here, where 1 kilometer would be 10 to the 3 meters. At this point, kilometers is up on top. We're going to divide it by the kilometers on the bottom. That means that these 2 units have canceled each other out, right? Again, it's the same idea. If you divided 2 divided by 2, it equals 1. If you divide kilometers divided by kilometers, it equals 1, and essentially cancels each other out. Any questions on that? Now, setting it up this way, which is dimensional analysis, is really good because I could clearly see that my meters, which is where I would be at if I stopped the calculation at this point, is clearly up on top, right? And I don't want meters, I want millimeters. So to get rid of the meters that's on top, I should put the meters on the top or the bottom. Should I put on the bottom, which means I do want to use this conversion here to do that. And that would give me, what we got there, 1 millimeter is 10 to the minus 3 meters. Once again, the meters on top will divide out the meters on the bottom. And what we are left with at this point is millimeters up on top, which is the unit that we're actually looking to end up with. Any questions on that setup there? Now, mathematically, what we are doing is we are multiplying everybody up on top. So we're going to multiply everybody up on top and again, come back and divide by whatever's on the bottom. Now, in terms of your calculator, depending on the calculator you have, if you have a EE button or EXP button, you probably could just hit the exponent button and -3, or if you want, you could type 1 exponent button -3, however you want to do it. If you have that one with the will and the times 10 to the end, you probably should put parentheses and 1 times 10 to the -3. So here I'm going to take 12 times basically 1 times 10 to the 3. So exponent 3, I'm going to hit equals. I'm then going to divide it by basically 1 times 10 to the -3, which is on the bottom. So I'm going to divide it by 1 times 10 to the -3. And that's going to give me a big number here. 1, 2, 0, 0, 0, 0, 0. This is maybe why we don't write zeros, because I feel like I lost some. I see here, that's 3 and 3. So that is 3 and 3. I think I did all right, actually. No kidding. All right. Good deal. This also can be written in scientific notation, which will get rid of some of the zeros here, a little bit 1.2 times 10 to the 7, I think. And these would be millimeters at this point. By the way, significant figure-wise, what should the significant figures be? Should be 2 based off of this number. Remember that we talked about exact numbers. So that's considered an exact number. You don't have to worry about it when you're doing your calculation. This conversion would also be considered an exact number. So you do not have to worry about it when you're doing the calculation. So it is that first number. And actually, I think I did okay. I didn't put any decimals. So the way I wrote each of those would both have 2 significant figures. Yeah. Question on that? Yeah. Yeah, so let's see. We're going to multiply everything on top. So basically, we're going to take 12, going to hit the multiplication button, and then you would actually enter 10 to the 3 as is basically 1 times 10 to the 3 if you want to do that. So you would go 1, your exponent button, and 3, and that would do basically 10 to the 3. On a lot of people's calculators, like I say, you could probably just hit the exponent button, but if you want to be safe, you can do it that way. You then should hit equals, because that takes care of everything that's up on top. We're then going to come back and divide what's on the bottom, which is basically just this number. Everybody else is a 1. We're going to hit divide, and we'll punch this in the same way. You can go 1, exponent button. You do need your negative button because it is a -3, and 3, and then hit equals. Good. Yeah. Other questions? Fun with conversions. So again, sometimes people try to move decimals and stuff like that, and they do it wrong. So this is the best approach if you're kind of going again from a prefix to a prefix. You should really take it to the base unit. So why don't you try one? Why don't you try like let's do 555 decigrams to centigrams. So we'll do that. They're both here on this page, I think. There we go. All right. All right. So you want to convert decigrams into centigrams using those conversions. Okay, let's take a look. So first off, we're going from decigrams to centigrams. Our base unit is grams, so that's sort of the pathway is probably the best move to do. So take it from decigrams to grams, and then from grams back out to centigrams. Again, by looking at a table such as the one we saw on the previous page, you're able to really find those sort of conversions relatively easy. So in terms of deci, what that means is in 1 decigram, there would be 10 to the -1 grams. And for centi in 1 centigram, there would be 10 to the -2 grams. So again, that is the proper equalities that you would get from that. Again, from each of those, you could have two conversion factors, 1 decigram over 10 to the minus 1 grams, or 10 to the minus 1 grams over 1 decigram. For the other conversion, you could have 1 centigram over 10 to the minus 2 grams, or 10 to the minus 2 grams over 1 centigram. So again, here we're just going to do a conversion and go opposites of the units to make sure everything cancels out correctly. We're going to start with the number that we had, which was 555 decigrams. Once again, although it is not written as a fraction, the decigrams are up on top. So to get rid of decigrams, we want to go the opposite location, which means we do want to use the conversion factor over here to do it. That would give us 10 to the minus 1 grams up on top is 1 decigram. At this point, the units of decigrams should cancel each other out. And if I stop the calculation at this point, I would be in units of grams, right? And again, that is close to what I want, but I do want to take it now to centigrams. So by setting it up like this, again, we could clearly see grams are up on top, which means to get rid of grams properly, should I use the conversion factor on the left or the one on the right? Which one? The one on the left will actually cancel it because grams are on the bottom. So we got to go opposites to cancel out the units. We're basically dividing the units by going opposite is basically what we're doing. We're going to take 1 centigram on top, 10 to the minus 2 grams on the bottom. Once again, basically what we're doing with the units is grams divided by grams, which basically equals 1. So they cancel each other out. We're left with now centigrams up on top, which is good because that is what we're actually looking to end with. Once again, mathematically here, we're going to multiply whatever's on the top. And then we're going to hit equals. Then we're going to come back and divide by whatever's on the bottom, hit equals, and then divide and hit equals. In reality, the ones you really don't need to put in. If you want, you can, but you don't need to put them in. So if we did that, once again, that would be 555 as my calculator dies. Wake up, there we go. We're going to multiply it by 10 to the minus 1, which again is 1 times 10 to the minus 1. Put in scientific notation correctly in your calculator. You do want to hit equals at the end of that, and you should have something like 55.5 at this point. You then are going to divide by really 1 times 10 to the minus 2 on the bottom. And you will end up with 5550, and the units here would be centigrams. First off, any question on that calculation there? Once again, in terms of significant figures, this is considered an exact number, so you do not have to worry about anybody in there. This is considered an exact number, so you do not need to worry about it. Once again, like a lot of conversion problems, a lot of times comes back to the original number. And because the only thing you're doing in this type of calculation is multiplying and dividing, you're always looking at sig figs. So this is going to be 3 sig figs, and that's where we should end. So I actually did okay there. I got my 5,550 centigrams. Any questions on that there? Now, you may see some other conversions, by the way, for a similar conversion. Now, if I take 1 centigram equals 10 to the minus 2 grams, and I divide 10 to the minus 2 to both sides, those will cancel and give me 1 gram equals 100 centigrams. So that's how you get to the 100 we saw on the previous slide. It's actually divided it that way. So you can use the bigger number like that. If you remember that or see it, it works the same way. You'll get the same answer. So that conversion and the one up there in the box, which is this 1 centigram is 10 to the minus 2, they're equivalent conversion factors and they come out the same. So on some tables, instead of kilo 10 to the 3, they'll write 1,000. So those are all kind of similar. Any question on that? Prefixes or how to use them. So again, you do need to know how to use them properly, and you know when it says kilos 10 to the 3, how to use it in a calculation properly. And again, remember that is what one of the prefix units are to one of the base units. So if we look at some of these here, 1,000 meters is equal to 1 kilometer, right? So that would be a kilo is 1,000. 10 to the minus 6 is micro. They do write micro weird in your book. They use MCG. Most people use this little symbol for micro. Kind of looks like a U. It's not really a U. Most people use that for micro, but your book likes to use MCG, not to be confused with MG, which is milligrams or something like that. So if you see MC, it is micro in your book, but a lot of other books and stuff will use that symbol for micro as well. 0.1 of a liter is a deciliter. So that is our 10 to the minus 1 that we just used in the previous problem. That is the relationship there. Now, measuring lengths, again, some of these we do come across a lot, and this is sort of the opposite larger conversion. 100 centimeters is a meter. There are 10 millimeters in a centimeter. I think we talked about that when we talked about rulers earlier. And 1 meter is 1,000 millimeters. So these are all the ones. A meter is a larger unit, centimeters is a smaller unit, right? So you have a larger amount of the smaller to fit the bigger, right? If you have a really big bucket, you can put a lot of small stuff in it, right? So that's why the smaller number is larger, right? All right, so we talked about rulers and measuring those. Volumes, some common ones that we do come across. 1 liter is 1,000 milliliters. That definitely is one we do see a lot. And we talked earlier on, I think that 1 milliliter is the same thing as a cubic centimeter. So that relationship, it's a 1-to-1 relationship in terms of the volume, or if we didn't, let's talk about that in just a second. Again, we get something like a cubic centimeter by actually multiplying 3 length measurements together, like the length times the width times the height, and that gives you a cubic centimeter, which is a volume. Each of these individual units are lengths measurements. So if you take a length measurement basically and you cube it, it's a very common way. If you have like a cube, actually, just take 3 different readings and you can get the volume of a solid object like that by taking those measurements. And again, from any of these equalities, you could write 2 conversion factors. So if you had something like 1,000 milliliters up on top and 1 liter on the bottom, our 1 liter is 1,000 milliliters. So basically the fraction is just one's the numerator on top and one's the denominator, and you could use them in either direction. Just depends sort of what you're doing. Either you're multiplying or dividing basically when you use them. And there is our cubic centimeter. Also in medicine, right? cc is used as a cubic centimeter. So all 3 of those things basically are the same in terms of they're all 1-to-1 conversion. 1 milliliter is a cubic centimeter, and 1 cc, which is also a cubic centimeter. Typically used for when you just take a volume reading off of something like a graduated cylinder, or typically used when you take like some length measurements, and typically used in medicine as like in a syringe or something like that. 5 cc's and stuff like that is basically 5 milliliters. Any questions on any of that stuff there? Speaking of a syringe, there we go. All right. Mass. Now we might have talked about this, but in case we didn't, again, there is a difference, right, between mass and weight. Weight does take into account, again, the force of gravity. Mass is independent of it, and you should refer to things as the mass when you weigh objects. There's our micro, which is how most people use it. But again, 1 kilogram is 1,000 grams, pops up a lot. So does 1 gram, and 1,000 milligrams pops up a good amount of time. So I would say these 2 definitely pop up a good amount. And again, you could go 1 gram over 1,000 milligrams, or 1,000 milligrams over 1 gram. Now, typically when we have conversion factors, we obviously don't use both of them. We just pick whichever one that we need to cancel out the units correctly. Otherwise, if you use them both, you cancel out them both, right? If you use them properly, I guess they will cancel each other out. All right, identify the larger unit here, millimeter or centimeter. It is a centimeter, kilogram, centigram, kilogram. There you go. Deciliter, microliter, and microgram, milligram. Milligram would be the larger. So again, the smaller unit will typically have a larger amount, right? Again, to fit in the larger unit. Smaller unit will have a larger amount to fit in the larger unit. All right. So here we have 1,000 meters, once again, as a kilometer, and we kind of talked about these here. 0.01 meters is 1 centimeter. And by the way, if I turn 0.01 meters into scientific notation, that is 1 and 2, 1 times 10 to the minus 2 meters. And that is what you would see for centi, right, when you look it up on the table. So again, that is the same basically number, just written in decimal form. Yeah. All right, so 1 kilogram is 1,000 grams. 1 centiliter is, oh, sorry, that's 0.01 centiliter. I guess I should read the right number there. So 0.01 centiliters would be, I feel like I zoomed in, but I really didn't mean to zoom in, by the way. Let's see. I zoomed in on the wrong one, I think, but I just actually hit it, just zoomed. All right, it's actually 0.01 liters is 1 centiliter. I think their question was backwards there. All right. It would be 100, by the way, but I think they wrote it backwards. So I think they wanted 1 here, but they gave you the answer, I think, in that case. So I think they messed up there. Any question on that badly zoomed in question? Yes. All right. So in 1 centiliter, there is, so just so we're clear, in 1 centiliter, 1 prefix, there is 0.01 liters. If we wanted it the other way around, we would divide 0.01 to both sides. That would cancel and give us 1 liter is 1 divided by 0.01, 100 centiliters. So that would be the other conversion of that. I think they wrote the number in backwards there. Yeah. All right. Okay. So we've been talking about writing conversion factors. Again, really important for dimensional analysis, as we've been doing in some of these problems here. And again, it is really important to show the units in your calculation, show really these conversion factors where we get rid of 1 unit and end up with the unit that we're actually looking for. And that way, if you kind of keep things written like this, which is how you should do it, it makes it really easier just to pick out the correct conversion factor to use in the calculation. Because frankly, all you have to remember is go opposites, right? To cancel out the units, and you'll be able to pick the correct conversion factor that you need. So again, these equalities, as we've talked about last time as well, an equality really is 2 measurements that are on different scales, but they do represent the same amount of something. So 1 meter and 1,000 millimeters represents the same length. Just like if you had a pound of something, that's the same thing as you had 16 ounces. They represent the same quantity of that matter. And 1 kilogram is the same as 2.2 pounds. We have the 3 different types of equalities that you might come across. This is our metric to metric. This is our English to English, our US to US. And this is our English to metric. Now, when we think about exact numbers and we're doing calculations using equalities, if it is a metric to metric sort of conversion, it is considered an exact number, which means we don't really need to look at the significant figures. If it is an English to English or US to US conversion, it also is considered an exact number, which means you do not have to worry about the significant figures when you're doing a calculation. Technically speaking, when you do cross over to this line where we take English to metric, you should look at you should look at the sig figs. So for example, if we looked at this one, that is 2.20 pounds is 1 kilogram. If I could write kilogram, that's like a K, I think, yeah. Or 1 kilogram is 2.2 pounds. So because this really is a crossover between English to metric, we should really look at the significant figures. Now, when you do write one of these type of conversion factors, there will always be a number that is 1. So you don't look at that number. So you should always look at the other numbers. So this number would technically have 3 significant figures in the calculation. So if you do come across sort of a metric to English conversion, you should look at the significant figures in the calculation. There are a couple of exceptions. The popular one is 1 inch is exactly 2.54 centimeters. So although that is an English to metric conversion is considered exact, some people will do the 1 pound is exactly 453.6 grams, although your book may use 454 grams. So if you use that one, it could also be considered an exact conversion. So there are a few sort of crossover ones that are considered exact, and you wouldn't have to worry about the significant figures. But for the most part, if it is a English to metric, you should take a peek at it. With that being said, probably in most cases, not 100% of the time, but probably more times than not, even if you were supposed to look at one of those conversion factors that was an English to metric conversion, probably your original number will still have probably the lowest number of sig figs in most cases. So again, if you kind of go with the original number, you probably in most cases, again, not 100% of the time, but in most cases, you'll be probably pretty close to the right number of sig figs. But if you do come across one of these guys, you should take a peek at it and take it into account when you are doing the conversion. Any questions on that there? All right. So obviously, since we really use US, everybody else uses metric, we do see things written in both, which is when we look at the labels, right? Those little parentheses of how many grams stuff is in. Even our like street signs, right? And when we drive our street signs, a lot of times they'll have how many miles and then how many kilometers next to it. Sometimes you'll see those as well. So again, significant figures, if they are definitions, exact numbers, you don't have to worry about them. Only that crossover when you kind of go metric to English, you should take a peek at those guys. In this case, these guys would count towards the significant figures. So here, if we didn't use the exact number, which was that 453.6, but we rounded it to 454, that is going to be one that we should look at the sig fig. So this guy would have 3 sig figs. This guy would have 3 sig figs, and that guy would have 3 sig figs. If you use any of them in a calculation, for example, if you use 39.4 inches over 1 meter, or inches, our 1 meter is 39.4 inches. So again, if this was in a calculation, this is the number you should look at and decide, is that more or less than, say your original number, and that will help you decide how far you should take the answer to. All right. So there's our numerator and our mod. Now, sometimes we do get some numbers that we can turn into conversion factors. So for example, if we were driving 60 miles per hour, when you have 2 units, something per something, right? That basically means the number says with the first unit, we go 60 miles in 1 hour, or in 1 hour, you could drive 60 miles, right? Now, what happens if I wanted to know what is my speed in kilometers per minute, right? Can I do that? I could do that. So let's take a look at how we would do that. Go here with that. So let's say we were doing 60 miles per hour and we got all metric-y and we wanted to know how many kilometers, and we'll do kilometers per second. Why not? Change it up. All right. So in this case, we have actually 2 different units that we actually need to convert, right? We need to take the top units from miles to kilometers, and we need to take the bottom unit from hours to second, right? And in this case, we'll get a little helping hand here. Actually, we'll do a couple of things here. We need a path to get us there. So one possible path is to go from miles to feet. And you go from feet to inches. And inches to centimeters would take you there. And then from centimeters, you could go to meters and then to kilometers. That is a long journey. We also can find one where I'm sure here, I could steal one off of here, right about there. We have actually a direct conversion right about there. And that is 1 kilometer is 0.621 miles. So 1 kilometer is 0.621 miles. So that's a much shorter route, but you can take the top route there. And it also shows in conversions, you can take many different ways. It depends sort of what conversions you use. As long as you choose correct conversions, they all should get you in the same spot. Might take you a few more conversions depending on which way you choose. We also want to go from hours to seconds. So we want to go perhaps hours to minutes, and minutes to seconds is a good way, or you could go hours directly to seconds if you want. So for example, we do know in 1 hour, there are 60 minutes, I hope, yeah. We also know in 1 minute, there are 60 seconds, yeah. So we're gonna take kind of the shorter route here to get there. So we're gonna use these equalities here. And for each of these equalities, we could have 2 conversion factors. We could say 1 kilometer over 0.621 miles, or 0.621 miles over 1 kilometer. We could say 1 hour over 60 minutes, or 60 minutes is 1 hour. And lastly, we could do 1 minute is 60 seconds. Or 60 seconds is 1 minute. So in this problem, these are the 6 different conversion factors that we could use. Any questions so far? And again, like I said, you could shortcut some of this. If you know, right, that there are 3,600 seconds in an hour, you could go that way too. Instead of going from hours to minutes to seconds, it all should work the same. So when we get to this type of conversion here, it's important to keep our units really separated, you know, on top and on the bottom. And we're going to apply really the same approach of opposites will cancel. So we're going to start with our 60 miles up on top and our hour on the bottom. So the first conversion I'm going to try to do is get rid of miles, right? So miles are up on top. So to get rid of miles, I need to put it on top or bottom. So when I go to my conversion factor here, I should use the one on the left, right? That will do it for me. So I'm going to do 1 kilometer up on top and 0.621 miles on the bottom. If I stopped right at this moment with this calculation, what units cancel? Yeah, miles on top will divide out miles on the bottom. What units are left at this point? I have kilometers per hour, right? So I'm close to what I want. I actually did this part, right? So the top part of the conversion is done, right? We got it to where we needed. We're at kilometers. We shouldn't do any more to the top, right? Because I wrote it correctly here to start with, I could clearly see hours are actually on the bottom. So to get rid of hours, I would need to put hours on top. So when I come to my next conversion here, I'm going to actually use the one where hours are actually on top. And I could continue on here with the calculation. I'm going to go 1 hour up on top, 60 minutes on the bottom. Now I have hours up on top I have hours on the bottom. They will divide themselves out and they will cancel. If I stop right at this point, what units am I in? Kilometers per minutes, right? Both units are still there. That's close to what I want, but I don't want minutes on the bottom. I actually want seconds. So once again, by doing it this way, I could clearly see my minutes are now still on the bottom. So to get rid of them, I need to put minutes up on top. I guess the way I wrote these conversion factors, they're all on the left there. So we will use the one on the left. And we will have 1 minute up on top, 60 seconds on the bottom. Once again here, minutes will cancel. And that's going to leave me kilometers up on top, which is what I'm looking for, and seconds on the bottom, which is what I'm looking for. My conversion is done, yes, except for the calculation part. So we should do that. We're going to multiply, once again, everything up on top. And in this case, there's really not much to multiply because they're all ones. But you could take 60 times 1 if you like and hit equals. We're then going to come back and divide by this number and hit equals. Divide by that number, then hit equals. And we're going to divide by that number there and hit equals. Yeah. So again, and we might have talked about it, but you do want to avoid trying to like crunch all this stuff into your calculator all at once. You probably will get the wrong answer. Yeah. So you can multiply as much as you want on top, but individually probably go back and divide what's on the bottom. So I would go 60 and not really times it. I'm going to divide it by the first number, which is 0.621. I'm then going to hit equals. I'm going to divide it by the next number, which is 60, hit equals. I'm going to divide it by the last number, which is 60, hit equals. And you should get the right answer if you didn't hit clear like I just did there. So I'm going to try that again there. All right, there we go. Little 60 action. There we go. And if you do that, you will end up with a number on your calculator that looks like 0.026838432. By the way, the units would be kilometers over seconds. Number stays with the top unit and the bottom unit is always 1. Yeah, so that is how it will look. By the way, I feel like I use a little bit too much sig figs. What do you think? Probably. By the way, don't do that. It just annoys me. I've had people like give numbers and then it wraps around the back of the page. It's a lot. It's a lot of numbers. You shouldn't use that many. So let's take a look at our calculation and see what's going on here. I don't know. It's the end of the day. This is a conversion factor, which is an exact number, so we don't need to worry about it. That is also exact. This here is actually metric to English, which means we probably should take a peek. So in this case, that has 3 significant figures, right? We should also look at this, which is really badly written, but we'll go with it. It has how many significant figures? No, it actually has 1 the way I wrote that, which would have been a bad choice, but I did it. So really, we should end up with 1, which takes us to this lonely guy here. And that means that we should round that to a 3. And we should clean it up to something like 0.03 kilometers per second. Yeah. Question on that? Yeah. It is. So basically, mathematically, everything that we did here is basically multiplying and then we divided, right? So when we multiply and divide, we look at significant figures and it should be the one with the least number of significant figures. Now, we do want to exclude anything that's considered an exact number, which most conversions are. So this one here, again, is an exact number. We don't have to worry about it. This one is also an exact number. We do not have to worry about it. This conversion here, though, is really metric to English. So we should look at this number, which has 3 significant figures. And then that leaves us just our original number, which was 60, no decimal point written, which would have just 1 significant figure based off of the 6. And that means that basically the smallest number of significant figures here was our original number of 1 significant figure. And that's why we should round it to the 3 and just have 1 there. Yeah. Other questions on that? So the way we set this up, a couple of things about it is the way you really should do it. It is what is referred to as dimensional analysis. It is a skill you're supposed to pick up in this class. But more importantly for yourself, when you do it like this with the units, it was pretty easy to see, okay, this unit's on top, this unit's on the bottom. What it also makes it really easy to do is understand what you should be doing. Should you be multiplying these numbers? Should you be dividing these numbers? When people do this type of calculation, like this exact calculation, it is super common at the end there. They're multiplying by 60s because they have no idea where like the seconds is, the hours is, because they do what I like to call the stacked version of this calculation. Like I'm just going to kind of divide it by 60, or maybe put 60 and not really sure where any of the units are. So what it very commonly happens in a lot of places is these numbers end up on top and you're multiplying when you should be dividing. So by setting it up like this, you could clearly see, oh, it's on the bottom, I need to divide by that, or it's on top, I need to multiply by that. It helps you not screw up the math part of it, which is a very common mistake people will do. Any questions on that? Now, I also did this all in one calculation, and you don't necessarily have to do that. You could do the first sort of conversion, get an answer, take that answer, do the next conversion, get an answer, and so forth. If you do that, as we talked about, you don't really want to round to the very end, because every time you round, you will move yourself kind of further away from the right answer. But you definitely could do that and just kind of do in pieces. If you do, when you get the answer, take it to a couple of digits past where you should stop in terms of sig figs, and that way at the end you'll be okay. And that's the best way to kind of do it. Any questions on that there? All right, let's take a look at some of these equalities, some common equalities. Once again, anything in this column is considered exact. Anything in the US column or English column there is exact. And again, here you should look at the sig figs except for the one that is labeled exact, right? So you don't have to worry about that one. Now, again, some of these that come up, we kind of talked about earlier coming into this slide, but really a kilometer, 1,000 meters, the milliliters and liters, definitely this conversion. The kilograms and grams, again, comes up a lot, and milligrams. Look, some things may not be given to you like time. Yes, so hopefully you know some time. So we just did it right. So there are, how many seconds in a minute? Minutes in an hour? Hours in a day? It is 24, not 60. Another very common mistake people do, because they go like 60 seconds, 60 minutes, 60 hours. Way too many hours in the day for that. Yeah, so just 24. So again, some of those things may not be given to you. Yeah, so you do need to have some of that knowledge, but probably some of the rest there will be provided to you unless it specifically says it's not. But you do need to know how to use it and stuff like that. I know it's exams. Sometimes it happens left, right. You know, I did have somebody ask me that once, but unfortunately they came up to me in front of me and said left, right. So then I say my left or your left, depending on where you're standing. So it was very confusing. So that is a true story. So I had to turn around and go, okay, we'll go left or right. But things happen on exams. But again, if you use anything in that metric to US, you should look at the sig figs. Once again, you want to look at the actual number, not the part of the conversion that's one. So you want to look at the other guy in each of those cases. All right, so we kind of combined some of this in an earlier conversation, so we'll kind of just go through some of this. Again, two conversion factors can be used from any equality, and you can choose whichever one you want. All right. So we'll take a look at some of these. So 1 liter is 1,000 milliliters. And again, those are our two conversion factors, and the other conversion factors along the way, which again are really just those fractions that you could use, and keeping all the units sort of separated from each other allows you to hopefully pick the right ones to use. All right, so we kind of just did that, kilometers per hour. So again, like I said, sometimes you will be given some numbers in the actual problem that you can use as a conversion factor. And again, just like we did with miles per hour, we could turn this guy into our two conversion factors. And again, obviously use whichever one here. So in this case, that's kilometers to hours. it is given to us in a problem, so you don't always go 85 kilometers an hour, so it's really not an exact number. So you would look at the significant figures in this calculation. So if you were using that conversion factor in a calculation, you would count that as 2 sig figs and keep that in mind as you're doing it. So a lot of conversion factors that come from the actual problem, you usually do have to kind of look at the numbers and how many significant figures there are. For example, a tablet has 500 milligrams. So once again, you could have 500 milligrams of vitamin C in a tablet or so forth. Again, not all tablets have 500 milligrams, so it's not an exact number. So you would look at this in terms of sig figs as you're going through the calculation. In this case, it would have actually just one, the way it's written. There's no decimal point or anything like that. Any questions on that there? Very common is a lot of times we are given percentages that we do want to kind of convert into usable conversion factors. The easiest way to convert a percentage into a usable number is to assume you have how much of it? 100, yeah? Like your exam, if you got 80% on your exam, you probably got 80 points out of 100, right? So by assuming that you have 100, you can actually assume any number you want, but if you assume 100, it basically keeps the number the same. So that's the best way to convert something. So like this, you have 18% body fat by mass. Basically what that means is you got 18, as you see there, kilograms of body fat per 100 kilograms of body mass. You could also do it in grams, 18 grams and 100 grams. You could do it in pounds, right? 18 pounds and 100 pounds. So you can sort of be versatile the way you do it. You know, if you had a 4.5% by mass sodium chloride solution, you could just basically say that your solution has 4.5 grams of sodium chloride in 100 grams of solution. So that's just an easy way to turn it into a usable number. And you could also use it the opposite way. You could flip it over and do 100 grams of solution would have 4.5 grams of sodium chloride. So again, very commonly given to you in calculations, and you can convert it. In terms of significant figures, you also should probably look at the significant figures here, and you would look at the 4.5 in my example, which would have 2. You wouldn't worry about the 100 because you sort of exactly kind of pick that number. Just like here, we would look at the 18 and say that it has 2 significant figures and stuff like that. So kind of like what the original sig figs were in the percentage would be the significant figures you would count as a conversion factor if you were using it in a calculation. Any questions on that there? All right. Doses here, given some Keflex. There we go. 250 milligrams per capsule. Again, we would look at the 250 in this case, and not the 1 capsule. All right. So I think we're going to come ahead a little bit here. All right. So let's try this one here. If we want to look at this one, if a person weighs 178 pounds, what is his body mass in kilograms? So again, you may want to come back to our table there and look for a conversion factor between pounds and kilograms, which might be right about there. So 1 kilogram is 2.20 pounds. Yeah. I'll write that there where we're at. 1 kilogram is 2.20 pounds. All right, take a moment there, do the conversion, set it up using dimensional analysis to show. Okay, so from this equality, and this gives us a direct path from pounds to kilograms, we can go 1 kilogram is 2.2 pounds. Our 2.2 pounds is 1 kilogram. So once again, we're going to start with our number here, and that's going to be 178 pounds. So once again, the pounds are up on top. So to go opposite of it here, we're going to put it on the bottom so that they cancel. That gives us 2.2 pounds is 1 kilogram. Again, the pounds cancel. So we're basically dividing 178 divided by 2.2. And that's going to give us 80.9 kilograms. Yeah. 3 significant figures, because really we should take a peek at this one, which has how many sig figs? And this one has, which means our answer should have 3. Yeah, so all good. Any questions on that one? Yeah. That wasn't too bad. Hopefully they agree. That's a lot of slides to get there. All right. There we go. Rattlesnake. Speaking of things in bushes, here it's 2.44 meters long. How many centimeters long is our rattlesnake? So centi, right, is 10 to the minus 2, right? Okay, so centi, again, what this means is in 1 centimeter, there would be 10 to the minus 2 meters. Or if you want to use the other conversion in 1 meter, there would be 100 centimeters. So they're both perfectly fine to use, whichever one you want to use in this case. So we say the bottom one here, 1 centimeter over 10 to the minus 2 meters, or 10 to the minus 2 meters over 1 centimeters. That would be the 2 conversion factors for the bottom one. If you use the top one, 1 meter over 100 centimeters, or 100 centimeters over 1 meter would be the conversion factors for the top guy. So in this case, we're starting with 2.44 meters. Once again, we want to get rid of meters, so we're going to use the one where meters is on the bottom, either that one or that one, whichever way you like. So we'll go with 10 to the minus 2 meters is 1 centimeter. We're going to divide out the meters. That's basically 2.44 divided by 1 times 10 to the minus 2. Which gives us 244 centimeters in this case. This is an exact number, which means we don't have to worry about it. So we should come back to this guy, which has 3 significant figures. And obviously our answer here has 3 significant figures as well. Question, yeah. You can, but you need to show your work. So this is how you have to show your work. Yeah. So you got to show your work, especially even on these conversions where you're going from prefix to prefix. You do need to show your work with kind of dimensional analysis with the units and the conversion factors. Yeah. But in reality, we are just kind of moving decimals on some of this stuff. Yeah. Especially when you're going kind of prefix to prefix. So. Other questions on that there? All right. Hopefully they agree. That's good.